Right, had it not stayed within the parameters, it would have disengaged.
It would have shut itself down, yep. And the way you check that again is that green light. If you do something like that and you walk down here and that light's green, everything's working perfect.
And they said each element is 8,000, or what is the 4,000 watts, or 4 kW is it 4 kW per element?
Well,
you said 4,000 watts, right?
Yep. So what you're getting in that is not a true 4,000 watts per element because of these first two. So you're getting 4,000 watts per light plus whatever that percentage is of 8,000 watts.
And 8,000 being the first two bands.
Yeah, exactly.
And I got it on video, but could you walk through that step again?
Okay, so as you begin water contact on the turbine,
right,
the frequency is going to start up.
Right.
And it'll come up to 60, and at the point it reaches 60, the voltage regulator kicks in.
Yep.
And you start getting power production. Then this percent load is going to start up.
Yep.
At 50%, you have one full element engaged.
Okay.
It's going to keep right on going, and when it gets to 100%, the first two will be fully powered. And at 101%, the first step comes on and replaces that. This needle will bounce back to 50.
Okay.
And as you keep producing power.
Okay.
And in reality, when you bring that gate up in there, that all happens pretty dang fast. Because you're going from.
So I guess in a world where it was fully used.
Each step is a 50%. And so each time you engage a new phase, then it drops to 50, and then 50 to 100.
Exactly. And so it just keeps loading up. So what you'll do is control it pretty well through the first one or two, and then that gate is moving so fractionally that it's going from 60% to 100% in an inch of movement, and
So if you were complete field load, none of those lights would be on. So.
Well, it would meet all the demand load first.
Demand load, right?
If you had that switch closed, and then it would.
Gotcha. Okay.
So, and that's the one thing here when you fire this back up that you really don't want to do, because there's about 250% of production capability and demand load out there. So what will happen is it's trying to meet demand load, but all the freezers are starting, all the refrigerators, all the water heaters, everything's coming on at once. There's more demand load than the generator, so it won't get to 60 hertz.
I gotcha.
And it'll shut itself down.
Okay.
Except you've got a hold of that manually, so then you run the risk of running everything in brownout.
So the best thing is just do what we're doing there, run the generator, and then
do a hot swap.
Exactly. Because then everything's randomized.
Is there enough power? I mean, obviously, if you don't have that running and you flip, you have a brownout, or you have the inability to start it without disconnecting loads, right?
Exactly.
And so you may have to take a house offline, right?
So that's the next step, exactly. So there's the two. So top one goes to Grant's in the shop, bottom one goes down to your folks's.
Okay.
So you can just, if you run this up and you can't get there,
Take
drop
one
one of them off, let it run for 10 minutes, catch all the, that up, and then throw the other one in.
Versus having to run up there and do it.
Exactly.
So what this here is just your big transfer, internal transfer, or what's this?
Well, so it doesn't have anything on the other half of it. So it's in the design because one of the early deals was to bring grid here.
Okay.
So
that's just a.
Yeah.
Is
so
it?
It's a disconnect which is required, but we put a transfer switch in just so we wouldn't have to rewire the whole system.
Okay.
If you ever brought,
If we're trying to feed Idaho power.
Exactly.
I got you.
Exactly.
So is there anything in here worth noting?
No. That's gotta be it. Oh, that's worth noting.
Okay.
So so we're still in the feed. You can't get that box open.
Okay. Because
So-
we're still feeding.
Yeah,
Okay.
because we're still feeding.
Makes
through it.
sense.
Yeah.
Okay.
So, but what you've got is 3 sets of contacts in there, and a big knife switch that's 3 positions. One set of contacts is just open.
So we're not going to be able to necessarily. I guess we could shut it down at some point. I'd like to get this out of here.
Oh, well, that's, yeah, and that's just a matter of turning the breaker off and supply the power.
Oh, to
it.
the, okay, of course,
So
right.
that's,
So
yeah,
what,
that's a
the
non-issue.
correlation between this, and I understand where these are in circuit, how do these play into here?
Well, it's just a double feed. So you've got a feed to this, and then you've got a feed to the main bus in this. So this is just individual circuit protection because we didn't have enough panel capacity in here to get that many circuit breakers in.
Oh, so it's just a
Okay.
continuation of this.
Exactly.
So these are load, I'm just looking at the breakers, step one, step two. So these are the other steps.
Yep.
The first step, step one, step two.
One of those is
These-
off right now.
So these
Yeah.
are two for step one.
So it,
there.
yeah, and it's burned out is why it's on. So
Step two,
Yeah.
and then
Oh,
step,
okay.
so step three is actually, so these are the two that are always hot, the first step one and step two.
yeah, so because this step is burned out in the computer, I've got it just hooked up direct, so you can just flip that on or off. So
Okay.
now we're making a surplus of power. It's on all the time. If you get down to where you're overloading this unit, you can turn it off and
Okay.
pick up another 4,000 watts of demand load.
Okay.
That's when I get done here. Like I said, we won't have time to do. Okay, when I get done here, that'll all be back like it's
Okay.
supposed to be. And
Okay.
Okay, never mind, I got it.
change out the computer. We'll probably have to change out that. one
And you said you
resistor.
changing out the computer or just some of those?
No, this you got to change this whole computer module. There's nothing in there.
Oh.
Yeah, that's all solid state support and resin, and there's nothing repairable.
So what that is to control the lights only, or what other issues are going on with that?
Well, it's controlling these relays, and it's so
It's
you
the
got-
brains of the whole
Yeah, you
system.
got
Right.
two triacs. Yeah, so it's monitoring those. It's monitoring a digital clock and an analog clock for,
Which-
for makeup.
Yep,
So,
yep.
so as your switching's happening, it's getting a little higher, a little low, but it'll automatically make that up, and it's controlling the master voltage to the degree that it affects frequency.
Why not? I
Would it make any sense to get a duplicate control system?
Well, they're $3,500 and up, and I mean, I had to go to Alaska to get the replacement one I got because they were so far behind in production in Canada. We were 2 years out. So
Well, I'm just thinking like if this goes, you're done, right? I mean, until you get,
the reality is they don't ever go. You'll lose a step or two, but they just don't.
that's why we're replacing it, is because
Yeah.
there's a step gone.
I've never cooked one. I've never had a non-functional because of that computer.
they're pretty solid.
Yeah. So what you can always do, even if you lose 2 or 3 steps, to get you can either nozzle down and quit making as much power,
Right.
or you can bypass the relay and load them up with the circuit breakers
Okay.
and do it manually. But I've never had that one of those go completely. They're just the most damn bulletproof computer I've ever been around in my life.
Okay.
That one's 25 years old, been through at least 1 lightning strike, 2.
Yeah, I was gonna say they have the surge protection in there, whether the triacs or whatever
Yep.
they're using.